Hello and welcome to Crazy Math Productions. Today we're going to be looking at graphing linear inequalities in two variables. Now, by moving to two variables, we're going to need the potential to graph in two number lines, and that is a coordinate plane or Cartesian plane. So in inequality, we're going to have one of these symbols, less than, greater than, less than or equal to, or greater than or equal to. A solution is going to be something that's going to plug in to make this true, it's going to make a true statement into my inequality. So let's look exactly what these solutions are. Now we wanted to determine if the ordered pair is a solution to the given inequality. So in this case, let me zoom in a little bit. Okay, so I'm going to label these. We have x and y. Now, y, which is 12, is greater than negative 2 times x, which is negative 3, plus 4. I'm just going to plug this in and work out both sides of the inequality until I can tell if this is a true statement or not. 12 is greater than, that's 6 plus 4. 12 is greater than 10. Now, if you look in the number line, not that you necessarily need to do this, but just as a helpful hint, if you were to graph these two, 12 and 10, if you were to look with your hand, I'm going to draw some amazing hands here. Literally, if you look at the right hand, I'll tell you we need to rotate this a little bit. Okay, that doesn't match up. This does. Okay, so just a really stupid way to help you here. This means that it's going to be to the right on the number line. That's the greater than symbol. So it's going to be to the right on the number line. Well, 12 is to the right of 10 on the number line. So 12 is greater than 10. So this is a true statement. And determine if it's a solution. Yes, it is a... move my hand here. Yes, it is a solution. Because I plugged this in, and it was true. Okay, let's try another one. Again, I'm going to label x and y. I'm going to plug in y, so 3 times 1 is less than 4 minus 3 times 2. So it means 3 is less than 4 minus 6. 3 is less than negative 2. Again, let's sketch a quick graph here. 3 is going to be to the right. Again, 0 would be somewhere around here. 3 is going to be to the right on the number line, so it's saying 3 is less than or to the left of negative 2. If you notice, 3 is to the right of negative 2. It's not to the left. This is false. So no, it is not a solution. Okay, number 3 here we have x and y. Alright, we're going to plug in x, so 2 times negative 2 plus 4 times 3 is less than 8. 2 times negative 2 is going to be negative 4, plus 12 is less than 8. Negative 4 plus 12 is 8. Now, this one's a little tricky. If you're thinking about it, of course, I could just graph the 8. Is 8 to the left of 8 on the number line? Well, no, it's not. It's 8. It's equal to. Now, if you had or equal to, if you had this little line there, if you had the or equal to, then it would be true, but it's not. So, no, it is not a solution. Okay, number 4. Got x and y. plug these in. So y is 0 is greater than or equal to 1/2 times x minus 4. Well, half of 6 is 3, or you could put the 6 over 1, rationalize it. Multiply 6 times 1, 6, 2 times 1, 2, and 6 divided by 2 would still be 3. Now, 0 is greater than or equal to 3 minus 4 is negative 1. So 0 is greater than or equal to negative 1. Well, let's just sketch it real quick. Here's 0, here's negative 1. You may notice, okay, it fits my right hand here, so it's to the right. 0 is to the right, or is greater than, or equal to negative 1. Is, oh, what in the world? 0 is definitely this way on the number line. Make sure that you graphed the number line correctly, as I had not. 0 is to the right of negative 1. Well, yes, it is. It's to the right of negative 1. 0 is to the right of negative 1. It's greater than negative 1. So yes, this is a solution. Okay, now we're going to graph these. Now, if you remember, this is the young man. The young man is foolish and keeps his mouth open. This is the old man. He's got the wrinkles, or equal to. An old man is wise and knows how to keep his mouth shut. So, we put everything in slope-intercept form. Keep in mind that if you multiply or divide by negative, you have to flip the inequality symbol. And then you can use the test point to determine which half plane to shade, or you can remember a very simple trick. Okay, there's a nice trick. A good friend of mine, John Altman, taught me. Eat the y to the sky. Eat the x. Hit the decks. So thank you, Mr. Altman, for that. Appreciate it. And this is very, very simple. So if we have, for example, y is greater than or equal to 1/2 x minus 3, you see this little alligator, whatever you want to call it, is eating the y. I'm sure you've seen. I'm going to give you my mighty alligator worm thing here. So in this case, it's eating the y, so you shade to the sky. So if you have your, in this case, a little quick sketch up here. 1/2 x minus 3, and we have, that's my slope m, this is my y-intercept b. So we're going to the y-intercept, negative 3, down 3. I'm going to put a point there. We're going to rise 1, run 2. In fact, we could do it again. Now, it's the old man, so it's a solid boundary line. If it's the young man, then it's a, again, where we had the open dot, now it's going to be a dotted line. And where we had the solid dot, now it's going to be a solid line. So this is going to be a solid line. And basically, eat the y to the sky, so we shade above the line. You could also plug in, say, the point 0, 0, and see if it's true. So let's plug in the point 0, 0. It's shaded, so it should be true. So let's see if that works out. 0 times 1/2 is 0. Minus 3 is negative 3. 0 is indeed greater than or equal to negative 3. So we've shaded this correctly. It's always a good idea to go ahead and pick a point, say the origin that's off the line, and just make sure that it truly, in this case, this should have been shaded, the origin right here. This should be shaded, so that should be a good point. That should make the inequality true, and it did. So this did work out. Eat the y to the sky, eat the x, hit the decks. All right, so we're going to graph each linear inequality. Well, first things first, we have to make sure it's in slope-intercept form, which it is. Remember, slope-intercept form would be y equals mx plus b, except now this equal sign can be an inequality of some kind, less than, greater than, less than or equal to, greater than or equal to, or not equal to, although we're not going to graph not equal to. Graph each linear inequality. So, but we're going to go down 3. That's interesting. We just graphed this. Funny, that should pick that point. 1, 2, 3. We're going to rise 1, run 2. It's going to be a young man. So it's going to be a dotted line. And there's a dotted line. And we're going to shade. I like to use just a cross-hatching here. Eat the y to the sky. So we're going to graph above the line. And then that's it. Okay, let's try number 6. Okay, it's already in slope-intercept form, so I'm good to go there. I'm going to put my slope as -2 over 1, rationalize it so that I have -2 as my rise and 1 as my run. So I'm going to go up 5, so rise 5, 1, 2, 3, 4, 5. Put my y-intercept there. I'm going to rise -2, run positive 1. Rise -2, run positive 1. Now this is the old man, so it's going to be a solid line. And it's eating the little alligator here. The inequality symbol is eating the x, so we're going to hit the deck. So we're going to go below the line. And there we go. Number 7. Now, in this one, I cannot graph it immediately. I have to put it into slope-intercept form. So that's what I'm going to start with. I'm going to keep change here. I'm going to subtract 2x from both sides. Get a marker that's a little smaller. So -3y is less than -2x plus 6. And then I divide by -3. Whoa, what happens? We have to switch the inequality symbol. So y is greater than now. Negative divided by negative is a positive 2/3 x plus positive divided by negative is a negative. Or I could write it as y is greater than 2/3 x minus 2. So now I'm ready to graph. I have slope-intercept form. I'm going to go first with Moby and the boat if you follow Crazy Math Productions. We're going to start with the boat or the y-intercept. We're going to go down 2 because it's -2. And then we're going to rise 2, run 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And I only had to put those 2 points, but adding a third just gives me a little extra stability with the line to make sure that I'm drawing as accurate as I can. Now, it's a young man. It doesn't have the or equal to, doesn't have the wrinkle there for the man's eyes. And so he knows he is not wise, and he keeps his mouth open, or in this context, we're going to have a dotted line. And now, let's try green. It eats the y, so we're going to go to the sky. So we're from the line, we're going to go to the sky. We go above that line. There we go. Okay, and let's look at number 8. First things first, we have to get it into slope-intercept form, so we're going to subtract x from both sides. Get the right size marker here. We have 2y is greater than or equal to the opposite of x minus 4. And we have to divide by 2. And to make this easier on ourselves, let's go ahead and put a 1 in front of the x just to help you visualize what's happening here. We're going to make this -1/2. Pull down the x, and this is minus 4 divided by 2 is 2. If you can divide that, you might as well go ahead. And the negative here, where do I put the negative? Well, again, remember that you have three options. You can have negative 1 divided by 2, or 1 divided by negative 2, or just plain the opposite of 1/2. For our purposes, one of these two is going to be better because we'd rather see a distinct rise and run instead of having this negative just floating out here somewhere. So we're going to go ahead, we're just going to move the negative to the top, just out of habit, just easy to work with. But you do need to be aware that there are three options there. So we're going to go ahead, and it's in slope-intercept form. We're going to go down 2 on the y-axis for the y-intercept. We're going to rise negative 1, that is go down 1, and run positive 2. Let's do that a few times just to make sure that our line is accurate as we can. Now, this is the old man. He's got the little wrinkle there. This is going to be a solid line. And eat the y to the sky. So we're going to shade above the line. Okay, now let's work on y is greater than 4. Now, I'm just going to imagine for a second that we did not have an inequality, that we had y equals 4. Just imagine for me. If we have y equals 4, now, if you follow Crazy Math Productions, you remember that the axis is the opposite of what the line would be. So, for example, this is the y-axis, so this is a y equals type of line. This is the x-axis, so this is an x equals type of line. It just happens to be that they're the opposite of whatever axis it would be. So y-axis is vertical, y equals is horizontal. X-axis is horizontal, x equals is vertical. Now, we're dealing with a y equals type of line, so it's going to be a horizontal line. So I need to go where y equals 4, that's on the y-axis. Where does y equal 4? 1, 2, 3, 4, it's right here. And then I'm going to put a horizontal line. But it's not just a horizontal line. I'm dealing with an inequality. And now I've got to pull back in the inequality bit. This is a young man, so this is going to be a dotted line. Dotted line. Also, I can't go with the eat the y to the sky thing because there's only one variable. I'm going to have to go the old-fashioned way. Pick a point, like in this case, 0, 0. And let's see if this works. If I plug this in, see if this works. I'm going to label this x, y, and I'm going to plug in the only thing that I can possibly plug in. There's no place to plug in an x, but I can plug in a y. So let's plug in 0 for y. 0 is greater than 4. Well, that's not true, so this should not be shaded. We should shade on the other side. And there we have it. Okay, and one more. Again, if the x-axis is horizontal and x equals line is going to be vertical, what does x equal in this case? Negative 2. So I'm going to go on the x-axis to negative 2, put a point, and then put an x equals type line. Well, it's going to be a vertical line. The problem is we don't have an x equals, its x is less than or equal to. So this is the old man who keeps his mouth shut, so it'd normally be a shaded dot or a solid line. So we're going to put a solid vertical line. And now we have to pick a point, say 0, 0. In fact, 0, 0 usually works. Let me show that it'll work for something else. Let's pick, say, 2, 2. Let's pick the point 2, 2. All right, x is 2, y is 2. Now, we can't plug anything in for y. We can only plug in something for x. So let's go ahead and plug in 2 is x here. So 2 is less than or equal to negative 2. Now, if you recall, 2 is actually greater than negative 2. It's not equal to either. So this is not true. That point is not true. That means it should not be graphed. So shade on the other side. The basic process when you have one of these single variable, of course it could work for these others as well, but if you have a single variable, what you're going to do, x equals x-axis, it's going to be the opposite of the axis to determine whether it's a vertical or horizontal line. If you follow Crazy Math Productions, we call that swat the flies. Then we're going to take a point, any point will do, preferably off of the line, and we're going to plug it in and see if it works. Now, if it works, that side should be shaded. If it doesn't work, that is, it's not a solution, then it should not be shaded, and we should shade on the other side of our line. And that will do it for Crazy Math Productions today. Thank you so much for watching.